something is not working, let me know. But yeah, let's dive in. So thank you so much for the presentation and for having me here. Very happy to share um, our research and the things we care about at Cohere Labs with all of you. So the presentation, it's divided in three main sections. Um, I think I will try to leave a couple minutes between sections for questions if we are good on time. Um, if not, we can. I will definitely have some time for questions at the end of the presentation. But yeah, let's dive in. I'm going to be talking about multilingual first language modeling and basically how we approach designing and creating AI systems that are multilingual, um, represent languages equitably, and also understand culture and what are the limitations with the current approaches and what we need to do next to overcome those limitations. Um, so first things first, what is Cohere Labs? Well, Cohere Labs is a research lab that is dedicated to pushing the boundaries of what AI and large language models can do. And we try to operate at the intersection between um, open research and real world applications. We do fundamental research, but we also want our research to be useful for people. So we historically in the lab focus on a few different topics, but today we're going to be discussing making AI truly global and how we do that. So yeah, let's dive in now with the presentation. Um, yeah, basically all the LLMs nowadays, the frontier models are all multilingual. You can talk to Claude or Gemini or ChatGPT in a lot of languages. They likely have some knowledge of even like low resource languages or local dialects. Um, and this initially happened by accident because researchers, practitioners just throw in all the data they could find on the internet for training. Um, but yeah, nowadays is better. But even if it's better, not every language is represented equally, and that is a problem. Um, and this happens because most of the research still happens in English. Most of the innovations are tested in English, and researchers assume that it's gonna just work on every other language. And this last one is a big problem. It's also because a lot of the evaluations are in English, or they cover just a handful of high resource languages, but they don't cover a lot of languages that are spoken in many parts of the world. So this has a lot of implications for accessibility, for safety, for inclusion, um, and we thought we could do better. So yeah, let's figure out where the problems are. The first problem is that most of the data out there that we can find on the internet that is used to train models is in English. And this is a problem because nowadays we use models to generate data to train other models. We generate data synthetically, and if the model we're using to generate synthetic data or to do translations doesn't understand the language, the data that is going to generate is not going to be high quality. We also use models to evaluate models. So if the model we are using as the evaluator of the or judge doesn't understand a language, how can we trust that the evaluation is correct? And also generating data in a lot of languages, it's more expensive, it's slower than in English or high resource languages. So we're gonna look at how we developed TinyAya, which is a massively multilingual model that we released a couple of months ago as a case study of how we tried and hopefully we managed to do things better. So first of all, I'm going to introduce TinyAya. The TinyAya family is consists of 5 different models. We pre-train a 3.3 billion parameter model on more than 70 languages. And then we perform some post-training on that model to generate 4 different variants. One Tiny AI Global that is trained on 67 languages and performs. You can chat with the model. It's instruction fine-tuned, and then 3 regional variants that focus on different subset of languages. So with this model, we wanted to advance how different languages are represented. Uh, our goal was not to be the best in English or some other high-resource languages, but to be the best across languages and to be good in those languages that are historically left behind. So in this case, we can see that we are competitive in a lot of languages, but when we go to African languages that historically have been left behind by a lot of the open source AI systems, we perform um, quite well compared to these other models, but also quite well overall. Performance still a bit behind other clusters of languages, but we're getting there. And we did that because we had this multilingual first mindset. We did a multilingual first approach for training. And the way this mindset can look like is that we take into account all the different languages and the different characteristics. So we look at how the language works, the script, how it's written, the grammar, those things. We also, for training to generate data, to obtain data, we chose methods that had been tested on many languages, and not only in English. And when no such method exists, we just develop it. And finally, we also tested our models as much as we could with different techniques to make sure that we were performing well on every language we claim to support. So to be more specific and yeah, to show what are we gonna look into detail now. Things we did were looking at the tokenizer, and we designed a new tokenizer that was balanced across different languages and families and scripts. We also collected and filtered a lot of data in pre-training to have a large corpus of data, but also that we knew it had high quality. Um, for post-training, we looked at multiple ways of augmenting and generating data for all of these languages that we support. And during evaluation, our main priority was to minimize variance across languages and regions. We didn't want to be very, very good in English and Spanish and German, and then very bad in Welsh and Zulu and Swahili. Like that was not our goal. We wanted to be good enough in as many languages as possible. So let's look into pre-training data. Everything starts with the tokenizer. The tokenizer is the first piece that you design and train when you're looking at LLMs. And there is a problem nowadays, and is that with some tokenizers, certain languages are represented using more tokens. So in this example, like this is basically the same text in a few different languages. And we can see that for Spanish or English, each word corresponds to 1 token. And the tokenizer, for those of you that are not very familiar, is basically some sort of dictionary that translates words into a numerical representation that the model can understand. So in those high resource languages, you have a good representation. Like the tokenizer learned that hello or hola are things that are important enough to deserve 1 single token. When we move to other languages that have less resources to train from, words are segmented into multiple tokens. And this means that because a lot of those models out there charge people per token in the input and the output, generating information with models is more expensive for low resource languages. Training is less efficient. Generation is slower. There is a lot of wasted capacity, and the tokenizer cannot be fixed later on. Once you have a tokenizer, you need to stick to that tokenizer. So what we did was just looking at this problem from first principles. We looked at all the different languages we wanted to support, and we split those into different groups or buckets in such a way that we could um, have a good representation of different languages and scripts. So basically, each bucket contained a family of languages that had some similarities. Either the same script or they belong to the same family of language. And then we were able to give those buckets different weights. So some of them were up-weighted, some others were down-weighted to have a more equal representation of those languages. And we also extended the vocabulary size to 262,000 entries, which, to the best of my knowledge, is one of the biggest tokenizer vocabularies that are out there, at least on open models. And if you want to dive deeper into this topic, we published a paper. It's linked there, so it's on the archive, and you can check it out. The results are that our tokenizer is quite efficient across multiple languages and scripts, and we consistently get a very low average token per character, which is good. Lower is better in this case. There are other tokenizers, like the one used for like GEMA models, that is also quite good. Yeah, overall, as we can see, for instance, Quen is okay in some languages, but when we move to mostly non-Latin scripts like Greek, it's quite bad. Yeah, so as I mentioned, we were trying to be consistent across as many languages and scripts. And now that we have a tokenizer, it's time to get all the pre-training data. So we pre-trained TinyAI on 6 trillion tokens in more than 70 languages. And for that, we collected data from large corpuses of public data. So Common Crawl is a very common one to get data from. And once we had all this data, our goal was to get the highest quality data we could and also have balance across different languages. So for that, we had to do a lot of filtering, removing data that was bad, using heuristics and deduplication because there is a lot of duplicated data in the internet. And finally, training classifiers. So for each language, we could obtain data that belong to a certain category. So imagine data that is talking about mathematics or history or natural science. We were able to get that data and also within those domains, things that had high difficulty or lower difficulty, and also avoid those a bit more or less depending on what we wanted to obtain. Sorry, I think there is somebody that is not muted. Oh. Yeah, but main takeaways are that we can make the tokenizer as multilingual as possible. And for that, we need to design it from first principles, and we can upsample what we want to we want the model to learn, right? Like we can do it by category and not only per language. We also had to invest in good multi-stage filters to get the highest quality data possible. Yeah, so that's on pre-training. If there is any questions up until now, feel free to raise your hand and ask. Otherwise, I'll continue with the post-training part. But I can answer a couple questions and then we can move on if anyone has any questions. All right,
Okay,
then, yeah.
does anyone have any questions to ask? You can kindly raise up your hands. Okay, there's a question in the chat, sir.
Oh, yeah. Don't see the chat right now, so it's
Okay, the question is, I'll read it out for you.
yeah,
Don't worry.
please. Right, chat. Yeah,
Is common crawl high
yeah,
quality?
I can see the chat now. Perfect.
Okay.
Yeah. So common crawl, is it high quality? Um, yes and no. Like basically, common crawl is a collection of snapshot of the whole internet. It's not the whole internet, but it's a lot of the internet. It's this public repository of every few months. They collect the state of the internet, and you can then download that information. And there is a lot there. There is some good information. There is some bad information. That's why it's so important to obtain the high quality data from all of that. Compared to by G5 type tokenization, how is a multilingual tokenizer? So for that, I would recommend taking a look at this paper, One Tokenizer to Rule Them All, because it has a lot of details. And I could go on and on for a while, but that paper has a lot of details, so I think that's gonna answer your question much better. How do you guys figure out the data before and after augmentation was fit to train? Um, we did run a few ablations with different types of like subset of the data and different data mixes to figure out which one was the best one. So yeah, was there any benchmark? Yeah, we did run evaluations after every ablation to figure out what data mix was the best one, and then we selected the highest performant. Yeah. Okay. Yeah, I'm gonna move on to the
Someone's hand
next.
is up.
Yeah.
Someone's hand is up.
Oh, yeah.
AAI, you can ask
AI,
your
please.
question.
Yeah, last question, and then we move on.
Okay, thank you. Please, good afternoon. Please, I just want to ask this question. So, was there a mechanism, if this was really a concern, but is there a mechanism to like validate that you had, let me say, something close to like a close ratio of data across all languages? Like, what are the ratios of the data you had during pre-training for the 70 languages in ratio?
Yeah, so your question is if it's important, like what are the ratios, or if it's important to validate that you have the right ratios? But I can answer both. So it is important to know what's going into your pre-training data. It's important to um, design your pre-training data corpus in such a way that everything is represented properly. When it comes to the exact ratios of pre-training data, I don't remember them by heart. Um, I know that obviously English was represented more than other languages because most of the data, as we saw, is available in English. Um, but we tried to have like a good balance between high resource languages and lower resource languages that deserve representation. So yeah, but I cannot share the exact numbers right now because I don't remember them. Right, perfect. So let's move on to post-training. And here this is the yeah, most dense part of the presentation. So stay with me. And for post-training, we have done historically in the lab a lot of work on post-training data. We ran this initiative couple years ago to obtain a massive post-training instruction data set called the AYA dataset, and it has some machine translation and some human annotated and human written prompts. And back in the day, it was a really good source of data. Um, but it's 2026. It's been like 2 years now. A lot of these completions are not really challenging anymore. We expect more from AI systems nowadays. What was good 2 years ago is not good anymore. Um, and it is a lot of like multilingual data, but it also had some issues. One problem we had is that for many of the low resource languages, um, there is still not enough data. And the high quality instructions sometimes are like mostly in English. And some common approaches that we use for augmentation rely on machine translation and using other models, like I was saying before, to generate some of the data. But translation has issues. Some quality varies across languages, and we can learn these translationese, which are like errors that you introduce during translation. When you use a teacher model to distill or to generate synthetic data, there is quality that is not constant across languages. So if you're using a model to generate data in many languages, some languages are going to have higher quality data, some others are going to have lower quality data. And translation, if you're translating from English, you are basically translating the intent, the meaning, but also the cultural aspects of like the English prompt into the target language. And that doesn't always apply. So we looked into all of this, and then we wanted to fix as many of these problems as we could. So we designed a multi-stage synthetic data pipeline that hopefully, I think we did achieve some of these, fix the translation is and include some more diversity and increase the quality of the data. So this is basically, in a nutshell, some of the approaches we use for all this data generation to fine-tune and move from a pre-trained model that knows how to complete sentences in many languages to a model that knows how to answer the user, which is quite more useful now that we all like agents and chats and stuff. Yeah, so standard translation. This is something that, even though we know there are issues with it, we've used in the past quite a lot. The AYA 101 model that we released in 2024 alongside the AYA dataset relied a lot on human on machine translation data. And one approach you can use is you have a dataset with your data distribution, and then you can translate and up weight and sample different datasets with different weights. So you end up with some sort of translation heavy data, but it's fine. The problem is that you usually your sampling distribution is usually over datasets, not over languages, and you can make that a bit more complex, but then introduces other complexity. So basically, your multilingual coverage depends on the multilingual coverage of the individual datasets, and if you are sampling per dataset and not per language, you're still sampling more of the high resource languages. And because we are using translation, then we introduce all these translation effects. And one example of this is that if you ask this model how do I get better at shooting at basketball, it's gonna give you, if you ask like in German, it's gonna give you a German answer. But then apparently, I don't speak German, but apparently it is talking about using some sort of gun. So I think the shooting part got a bit confused here. It's not the same type of shooting. And again, this was more than 2 years ago, before there were all these safety and evaluations and guardrails. But this shows that the issue with translation is that sometimes translations introduce unintended effects that are either unsafe or irrelevant. And yes, okay, we could translate all the data out there, but then we would include all these problems. So we will end up with a model that it might speak many languages, but it's not very useful. And that's because quality and diversity of data is much more important than the quantity of the data. So we could and can do better. So we experimented with different approaches. One of these approaches is what we call arbitration and fusion. So we have some English prompts, and then for all of these prompts, we generate from an arbitrary pool of models. So different models. We can use like Llama and Quen and Aya and different models. And then we create all these completions. And then from all these completions that come from different teacher models, we generate, we select the best one. And this is good because then we have so many candidates and then we are selecting what we believe is the best one among all of them. The problem is that we are wasting a lot of other completions that maybe are adding diversity or are also good or include some other information that it would be really nice to include in our answers as well. So we played around with this idea and came up with this extension that we call fusion and best of n. So we take all these generations, and then instead of selecting the best one, we ask another model to combine them into a new generation that includes the best part of all the other generations. So imagine we're asking about, I don't know, the history of Paris, right? And one model is talking about the Eiffel Tower, and another one is talking about Notre Dame. Then we can combine all of that and get a good response that is combining the best of each of those generations. And we evaluated that across multiple languages, and we saw that it is working, both for translation and some open-ended generations. So that was very nice and very promising. And we used some of this approach to generate better responses. Now, we have another problem, and is that we are assuming that all the English prompts we are using are good. And that's not always true. Maybe some of the English prompts that we're using, as I mentioned, we're translating that to other languages, and then they carry all the cultural connotations of the English language. And yeah, that's sometimes not what we want. So we asked ourselves, well, maybe we can, instead of like just doing translation, we can also perform some sort of transformation on top that, apart from translating the prompt, makes it sound more natural in the language we are targeting, or more culturally aware. So we basically did that. We translated the prompt and then applied a set of transformations on top. And here is an example of that. We can have this English prompt that is talking about Thanksgiving, like what is traditionally served during Thanksgiving with the turkey. And the translation to German is gonna look like this, but then it might not sound very natural to a native German speaker. So we can do a bit of editing, and we call that naturalization. But then Thanksgiving is not really something that people celebrate in Germany, so we can do a cultural adaptation of that. And instead of talking about Thanksgiving, maybe we can talk about Christmas, which might be more relevant to a German speaker living in Germany. But then maybe what is served with turkey during Thanksgiving is not a very difficult prompt. And we want to make that a bit more challenging because, again, it's 2026 and we expect more from our models. So maybe we can also apply a difficulty transformation. And instead of asking that, we can ask, give me the shopping list to prepare a Thanksgiving dinner. So instead of just some ingredients that go with the turkey, you need the whole shopping list to cook everything. And then we tested this, and we saw that when we apply this naturalization transformation, we increase prompt diversity, we increase quality, we increase fluency. When we apply the cultural adaptation, we also increase generation diversity and prompt quality. When we complexify our prompt, that leads to higher fluency, better quality, and we can mix and match all of these transformations. We can do cultural plus difficulty, we can apply the naturalization, and there are other transformations we can also applied to our data. So that was really useful, and on average, we did improve the quality of the generations in a lot of languages. But for some lower resource languages, we saw that quality was actually not getting better. So it was very important for us also to look into um, every single language. As I said, we didn't care about average performance. We care about being good enough in as many languages as possible. And the problem is that we still use models to generate data to train models. And if the models we're using are not very good in a certain language, then we can introduce some of these undesired effects and translationists and bias and many other things. So it's very important that when we're working on this set of transformations to generate new data, we still inspect the data, run quality checks, and remove bad data. So main takeaways are that we can optimize for translation quality, but we shouldn't just stop at translation. There are many other things we can do on top of translation. And AI systems nowadays are quite good at helping us in this process. We can also distill and generate data from multiple teachers rather than just a single one, and then combine the strengths of all these teachers. Some teachers are good in one language or another. Some teachers are better in one domain, and some are better in others. So we can combine all of these strengths of these multiple teachers. And that's very important. And then we can shape the prompt distribution. We can apply all these transformations, and that will shape the model. We can, given a data set, we can expand that. We can make it more challenging, more interesting. Yeah. So again, I think we are good on time. So let's stop for a couple minutes and I can answer some questions.
Thank you very much, Alejandro. I don't know if anyone has any question so far.
Yes, I have a question.
Go ahead.
Yeah, thank you very much for the presentation. I really enjoyed it. Looking at the target characteristics for training, post-training data. So I'm looking at it from a linguistics aspect. Yeah, so
Yeah.
you mentioned natural, cultural, and difficult. Yeah. So it's an observation, maybe not a question, but an observation. Maybe if you've tried something like taking the context into consideration. For instance, looking at low resource languages. So it's really important because some words they derive their meaning from context and not, so it's really different from cultural, for instance, or natural. So most of the words in low resource languages are ambiguous, so they can be disambiguated from the context. So I'm just wondering if you considered looking at context in this procedure or it was overlooked.
Yeah, no, that's a very good observation. And yeah, for sure, like context is very important and it also depends on the language. I think part of the naturalization aspect takes that into consideration. You can read more about this paper here, The Art of Asking. But basically, what we wanted to do there is the naturalization part or even the cultural adaptation. I think a mix of these will take that into account because we are trying to adapt the data to the language. We want the data to seem to sound more natural, more like it's coming from like a local speaker, coming from someone that understands the language and the culture. So yeah, it is not perfect, and there are things that can probably still be done, and some transformations that can be applied on top. but we saw that this was already improving things. But yeah, definitely there are languages that are very complex, and we probably don't cover every single nuance of like every single language out there.
Yeah, thank you very much.
Yeah, so there are a couple questions on the chat, so I will answer those as well. So one is up to this stage, what is the degree of human in the loop for data augmentation? We relied a lot on synthetic data. Some of the original data was inspected by humans in English, or in like not all the original data is in English. Some of the original data is also in different languages. But yeah, the main issue is that for the volume of data that is needed, we cannot inspect everything manually with humans and native speakers. And that's something we will see also during the evaluations that I will talk about next. But yeah, when you run all of these training and experimentation at the scale that is needed to train a good AI system, having humans validating everything is not feasible because of the speed and the amount of data that is needed for these systems. Yeah, so I think that answers both of the questions on the chat. Also, if given scripts in Thai or Tamil or Devanagari, does it solve or answer the questions? Yeah, I mean, give it a try. We do support Thai, Tamil. Yeah, we support all of these scripts and languages, if I recall correctly. So the model should, at the very least, be capable of generating data using these scripts. And hopefully, though, it should do it properly. So we have a Hugging Face space. So if you search for Tiny Aya Hugging Face space, I think it should be available there, and you can play around with the model. And we also link that from our Hugging Face model card. So you can test the model, and hopefully it works. We did put a lot of effort in making sure that things were working as good as possible. All right, then let's move on to the last part, which is evaluation. And yeah, we will have more time for questions at the end, both about evaluation, but about everything else. So if you have any questions later, I hope I have enough time to answer all of them. All right, so evaluations. Evaluations are a challenging problem. And it's because a lot of the evaluations, well, there are multiple things that happen during evaluation. One is that the datasets for evaluation that have high coverage are mostly in English or translated from English, and the quality of the translations, as we saw before, is sometimes not good because of the approaches used for translation. And there are also a handful of specific evaluations in many, many languages. But then those are like very tricky to include in your evaluation suite, because when you are evaluating, you want to get a signal of, you want to be able to compare across languages and across different runs and experiments, right? So if you use one specific evaluation for each of your languages, you don't really get the full picture of how your model is performing across the board. So you need to find the right balance here, and it's a bit challenging. Overall, there are many multilingual evaluations, but they are imperfect. There are many things that need to be improved. Language coverage, the amount of data that is in the evaluation. Like, yeah, for instance, there are some evaluations that contain less than 100 samples, which, you know, it's good if when those are high quality, but then it's quite easy to end up overfitting to those evaluations or saturating the evaluation. And then those ones that are not human translated and are machine translated then have issues, and they are sometimes hard to reproduce, and there is overfitting, etc., etc. So yeah, there is a paper going through all of these details that my colleague Julia published last year that I definitely recommend. But back to Tanya, yeah. So our approach to evaluations, our philosophy was a bit different to what I've seen in a lot of the other models. We, from the beginning, knew we didn't want to optimize for leaderboards. We didn't care if our model was the first one in like a leaderboard. We think leaderboards don't capture the whole picture. And one of the problems is that a lot of those leaderboards or many of the evaluations out there, they track the average overall across all the languages, and then the high resource language that are very good will dominate. A lot of the benchmarks are multiple choice question answering. So you ask the model a question and you give the model like a few options, like select A, B, C, or D, and then that's it. But that's not really what we do with models. I personally never go to a AI system and offer the AI system A, B, C, D, choose the best option, right? And finally, a lot of the evaluations out there just measure accuracy, right? Because if you give the model 4 options, then you can compute how many times the model got it right, and you get accuracy, and it's a nice metric, but it doesn't tell the whole picture. So something we did was in our evaluation, sometimes we couldn't evaluate on every single language all the time because we needed some sort of like fast iteration. But for sure, on most of the evaluations, we selected a representative sample of languages and scripts and families. And then we also ran some other evaluations on as many languages as we could. We focus on generative tasks. So we didn't really care about all these multiple choice questions. We wanted to know how good the model was at generating text, which is what models do. It's a bit harder, but it's way more realistic. And we were also looking at many other metrics, like not only accuracy, because when you are doing generative tasks, accuracy is a bit more difficult to measure, but is the model answering in the right language? Is the generation natural? Is the model following instructions properly? And we were also tracking not only the average, but also the minimum and the mean and the maximum scores across languages. So that's why we know that our model is quite balanced across the board, because our minimum score in like our worst language is still quite good. So one thing that we used to do in the past is having our model kind of like quote unquote compete against other model. So for one prompt, we generated some data with our model, some completions, and with a competitor model completions, and then we asked a third model, hey, select which one is better, right? So those are win rates. It's like one wins or the other one wins. And there are a few problems with this. One problem is variance. A few changes in style can change the score. Sometimes the judge you are using is a bit biased towards like more verbose answers or like a certain type of answer. And even if your answer is good and contains the right information, you're not going to win because the judge doesn't like it. There is no notion of absolute quality, right? What does it mean? What does it mean to win? How do I know that I won because I'm better, right? Because sometimes you win because the other model is very bad, but that doesn't help you to get better. And it's also very difficult to interpret, right? Like you don't know why you are winning, and sometimes you ask the model that is judging to give you a reason, but it's still a bit unclear. So what we did was we moved from this sort of win rates to 4 criterion rubric, and we were scoring models on a 7-point scale. So that helped us a lot because we had like different criteria that we will see next, and then we can get a score for uh, all of these criteria. So yeah, it was accuracy, instruction following, coherence, fluency. All of this is very important, and then we could understand why we were losing and what are the aspects that we had to improve. Another problem with win rates is that early on during the Tiny AI development, we saw that we had a 90% win rate against Gemma 3-4B, which was one of our competitor models because of the same scale, in Welsh. And that was like quite interesting. Like we were like, wow, why is our model so good in Welsh? Well, it turns out we were not that good in Welsh. It's because Gemma couldn't generate anything in Welsh. Like they claim to support a lot of languages. We don't know if Welsh is one of those. But basically, the model when we were doing data generation, Welsh was doom looping and generating the same thing over and over again. So obviously, the judge was picking our model because we were able to produce some Welsh test that was somehow coherent, right? But that doesn't mean it was good. So with this 4-point rubric, we could understand exactly what were the strengths and weaknesses of our model. We also did some discriminative evaluations. So these sort of multiple choice questions, because it's also interesting to understand these are evaluations that are widely used. And we know we are not really good at those, and we were not targeting them. We know that Quen is quite strong in a lot of the STEM and coding tasks, and we're not, and that's fine. It was just basically not one of our priorities. But in generative evaluations is where Tiny AI actually shines, like things like MDolly and Arena Hard that are just generated, like answering questions, or Flores or WMT that are translation tasks. So you still need to generate text. We perform quite well above other competitors. And that's not the only thing. You can perform better, but as we mentioned, like the average score doesn't tell the whole story. So as you can see, the number in between parentheses is the standard deviation. So you do the average, you compute the standard deviation, and you understand how good you are across the board. And our standard deviation across all the languages in these datasets is the lowest among all of the models we evaluated. And yeah, that's because we did focus a lot on being good enough in every language we could. And yeah, so this is a nice and interesting chart because here we are measuring the open-ended generation quality across multiple evaluation tasks on different sets of languages. And here we're grouping languages by how many like data availability in common crawl, right? And you can see that as data availability decreases in common crawl, we maintain good generation quality. And yeah, that's quite interesting, and that was very important. So even if there is less data available, as we saw, having high quality data and doing all this filtering and transformations goes a long way, even for low resource languages. Safety was also a very big focus. And that's because, safety is important. Most of the models out there go through some sort of safety training to uh, account for biases. Like we don't want our models to be racist or sexist or generate unsafe content when they are asked about some uncommon thing. But because a lot of models do not target every language equally, the safety training only works for high resource languages. And in low resource languages, you can perform what it's called like some sort of jailbreak. So you can generate unsafe content in low resource languages. And as we can see here, the mean safe rate is quite good across many languages, but the minimum safe rate drops a lot in quite a few models, and we also want it for our minimum safety. We want it to be quite good. And now, quite relevant for this session, but can Tiny AI also understand cultural nuances? So with all this data filtering, transformations, improvements, etc., we did include some of those cultural transformations. And we evaluated Tiny AI on 2 different evaluation tasks. And we can see that overall, we understand cultures fairly okay, even compared to other models like Command A, which is a 111 billion parameter model. We can understand some of the culture, but there is still a lot of room for improvement. So this is definitely not a problem we solved. This is something that we got better at, but it's still an open problem that needs to be worked on. So with this multilingual first evaluation, the main takeaways are that we need to carefully choose the languages to track and make sure that we go beyond averages and we look at variance, outliers, the minimum, the maximum. LLM judges are not perfect, but we can make them useful for us and use them to understand what needs to be improved. And it's important to track safety and take safety into consideration when we are developing models. But now we have a good recipe and technique to develop multilingual models, but we need to move beyond multilinguality. We need to go to multiculturality. We need to be able to understand all the regional aspects of languages and cultures because AI needs to work for everyone. And that's still a challenge. So some open research questions that we're thinking about, but I also encourage all of you to think about, is that, what are the aspects of culture that are captured already? And how can we make AI more culturally aware and inclusive? And we want AI to work for everyone. And what does it mean to have a culturally aware AI system? Like what do we want to get from it? Like it's not only about understanding the culture, but like what does it mean and what are we expect from that? So if you're interested in all of these things, some of my colleagues were discussing that recently. So I think you can scan the QR code here or like take a screenshot and scan it later to participate in a survey. But there is also a session that you can check. I think it's on YouTube. You can go find it. It's about culture in Cohere Labs. Yeah, so thank you so much. We still have some time for questions, but before we go into the questions, I also want to acknowledge all the work that the Tiny AI core team put into developing and releasing this model. This was a huge team effort. We're very proud of what we achieved. And Yeah, that was very nice. So I encourage you also to take a look at the paper. Well, the text report is on the archive. You can just like Google Teniaya archive, and we share a lot more details there that I couldn't cover today. And with that, I open for questions, so feel free to ask anything.
Okay, you can go ahead, PA.
Hello, thank you for your presentation. I saw that you briefly talked about MCQ. I wanted to know your take on MCQ in training and in testing models' cultural knowledge as well.
Like MCQ as in multiple choice questions?
Yes.
Yes. So as I was mentioning, with multiple choice, there is this like that we don't I don't think, and we don't think in the team that that's a particularly useful way to evaluate models because we rarely use those models that way. What we care about is if the model is good is able to generate good quality completions. But I don't know, we rarely show the model a question and for possibilities. So it's a good data to include, I guess, because some of this data contains a lot of general knowledge. But we decided not to focus on it because we believe it's not what we want from AI system.
What if the form of this text is not necessarily a question, but it's a statement and the completion, several completions with one being correct and the others being wrong, with very small nuances between the correct one and the wrong one, especially when we are training a model on, for example, differentiating between similar cultures. But
Yeah,
for each one can have a special, let's say, trait.
yeah, and there is one that is correct and three that are incorrect, right? Yeah, I mean, still interesting, but then the fact that your model knows which one is correct doesn't mean that your model knows how to generate the one that is correct, right? You can see those for like you as a person, right? Like sometimes it happens. You see a question and then four possibilities, and you are able to discard and select the right one. But if I don't give you any options, you don't know which one is correct. So my intuition is that something similar happens with all of these AI systems. Maybe the model is good at selecting the right one, but when you ask the model to generate text in a language with those cultural nuances, uh, it's incapable of doing that. And there are other ways to train models that can teach the model to generate the right one. You can include different data during SFT to teach the model the right words or cultural aspects. You can also go beyond and perform some preference tuning and reward the model when it selects the right one and give a bad score if it selects the wrong one. There are other ways that you can steer the model into the right direction. And yeah, I think it can be useful to include some of that, but I don't think it's the way to teach models how to generate the right thing.
Okay, thank you so much for your input and for the presentation.
Yeah, no problem. There is one in the chat.
Hey, Alejandro.
Oh yeah, go ahead.
Just a small question. Like you mentioned that many languages don't have enough digital data available on internet. So how are you guys or the team is planning to address that challenge for low resource languages in the future?
Yeah, so I think we have this pipeline that we explained with all this synthetic data generation, translation, and augmentation of prompts, and using different teacher models to generate new completions and combine those. And that's quite a powerful approach that showed really good results. I think in the future we probably will keep iterating and improving on this pipeline. And as models get better, we will be able to get even better data to create new models that can generate even better data. So it's an iterative process, but probably investing in this research and how to create, generate, and adapt data to more languages and cultures is the way to go.
I mean, like, does it have any major trade-offs?
It does have trade-offs. Obviously, the best approach, the best you can do is have human generated data because we all understand the language, but that doesn't scale. So you also need, and it doesn't give you sometimes the diversity you need. So yeah, the trade-off is that you're probably introducing some issues, but it's getting better and better. So it's the price you have to pay to get the volume you need to create better systems is that it's not gonna be perfect, but it's gonna get better as you keep working on it.
Okay, thank you.
Okay, I'll answer the one on the chat. Was there a base model using TinyAya? So it was completely fresh from scratch. We did all the pre-training data collection, pre-training, and then post-training data collection and post-training, everything from scratch. So if a model does not support a low-resource language, so TWI in Ghana, what approaches would you recommend to get a model do well without losing other languages? So that okay, there are multiple questions there. Yeah, so that's difficult, right? One of the issues is that if the tokenizer doesn't support your language well, then it's going to be quite difficult for the model to understand and learn effectively. We tried to solve some of these problems with our tokenizer. So we train our tokenizer in many, many more languages than the ones we support because we want people to be able to adapt our models. And then you have different approaches. You can get the base model and do some continuous pre-training. So you keep pre-training the model on the new language. And if you are going to do that, you should also include some data in the other languages to make sure there is no catastrophic forgetting. And then you can do all the post-training on top. That's obviously not straightforward because it requires resources and a lot of data for post-training and the continuous pre-training. You can also get a post-trained version of the model and then show some data in the language you want to train the model. Results are not going to be as good as with other approaches, but you can still hopefully teach the model how to answer some questions in your language. The short answer is there are a few different approaches. Each of them have trade-offs. There is no one solution that is gonna work perfectly. And it's a bit of a tricky problem, but it's still possible. Another question is, if you try to evaluate a model on Rouge, what training or data decisions will it inform? Well, Rouge is mostly used, at least historically, for translation. It's a metric that is interesting, but it's not about training and data decisions. It's about what you want to measure with the evaluation, right? Like you need to interpret that number. So it's very dependent on what you're doing, and there is also no right answer. It's just another metric that you're measuring, and you should be able to interpret that and understand what it means. Do you think Tanya Earth is currently the best in African language? It is the best small open LLM in African languages, to my knowledge. We, in our evaluations, were better than Quen and Gemma. Obviously, we need to understand this is a 3.3 billion parameter model, right? So ChatGPT uses a 1 trillion parameter model. Claude uses also 1 trillion parameter model. Bigger models are going to be better. And that's because they have much, much more capacity. But for the capacity we have, it's pretty decent. But obviously, you cannot expect the same capabilities from a 3.3 billion parameter model than a model that is 1, 2, 3 orders of magnitude bigger, right? That's a completely different type of model, so those are going to be better. Yeah, so for collaborations, it depends. You can send me an email, alejandro@cohere.com, or you can join our Discord server and talk about that. We are always happy to talk to people.
I think Yusuf has a question. So for the video, we are going to be sending it through email. So you'll get that after the section.
Yeah. Also, what's the name of the model you just mentioned? I mentioned quite a lot. I mentioned I mentioned Quen. I'm gonna write them on the chat. Gemma, Claude, ChatGPT, Tiny Aya is ours. So there are many. Yeah. Okay. So how do you prevent the model from amplifying its own mistake? Since you mentioned that outputs will be repeatedly used in future training. Yeah, so that's something you need to work on in your data pipeline. You need to filter out that data. You need to identify those mistakes and fix them. You can also fix the model if you know what mistakes it's making. You can do some preference tuning, preference alignment in your model, like using reinforcement learning to correct those and then generate data. So, but yeah, it's you need to figure out and identify the issues that you want to correct and then apply the right filtering pipeline or approach to correct those. Yeah. I mean, yeah, I did spend many hours looking at data in many languages for both pre-training, post-training, and obviously I couldn't look into everything, but with the help of also like some classifier models to understand what's bad quality and classifying high quality samples from bad quality samples, you can read the bad quality ones and try to figure out why they happen. You can also use some sort of LLM as a judge to score some of the prompts you generate and figure out which ones are bad quality. Yeah, you can play around with the model, and when it generates something that is bad quality, you try to understand why. So yeah, many different approaches, but yeah, you need to like look at the data and use the model and understand what's going on, and that takes time. What is the difference between cultural awareness of a model and cultural alignment of a model? Are they the same? If not, why? That is a very interesting question. I'm curious to know if any of you also have any thoughts on that. I might not have the correct answer, but I think there are some small differences. One, cultural awareness is probably when the model is aware of a culture and it understands where things come from and can reason about the culture. And cultural alignment, it's just when the model is very aligned to one culture, but it doesn't really understand whether something is part of the culture or not. I don't know if that makes sense. It's just something that is aligned means that by default, it's just going to generate data that is aligned with whatever culture or belief, but it doesn't mean that it's aware of the nuances and why something is belongs to a culture and not another. So yeah, I hope that answer part of the question, but if any of you have any other thoughts on that, because I think it's a very interesting question, please also share.
For my last question for you, it's not related to the presentation, but so I recently switched my job from project management to AI, and I'm quite relevant in this field. So I want to ask you if there are any fellowships or mentorships for opportunities for guys like me in AI research.
Yeah, so at Cohere Labs, we have a Discord server. You can find out that somewhere. And there are many people in that server doing research. It's like a nice community. People propose projects and they work on different projects. And from the Cohere Labs team, sometimes like once a year, twice a year, it's usually once a year, we organize what we call expeditions. So the last one was called Expedition Tiny Aya, where we helped people to form teams and work on research problems related to the Tiny Aya model together. And they each team had some mentorship from people working at Cohere. So we were helping and guiding people to do research. So that happens sometimes. It's not happening all the time. But if we are not running on one of those expeditions, some groups in the server also organize their own research projects.
Yeah, I saw some of those forms and links from the Cohere Labs, but the qualifications to apply for those were huge, and it was like not a chance for me to get into those.
Yeah, I mean, you can always try.
Okay, thank you for the presentation, by the way.
Yeah, thank you.
I had one last question,
Oh, okay.
only
Alright.
related to the name of Tiny Aya, actually. Is there a reason behind this name? It's really interesting to me.
Yeah, so basically the reason is that we have other models called Aya. So we have Aya 101, which was the first one that supported 101 languages. So
And
then we have Aya 23 that supported 23 languages. Aya expands that was a better version of Aya 23. I think we supported 30 something languages. And then we did Aya Vision, which had vision capabilities, so multimodal. And
for
in this case, we were like, oh, we want to do a small model based on the same ideas of being like very multilingual. And because it was very small, we just call it Tiny Aya. So
is
we're
there a
we're
reason behind the name Aya in the first?
oh, the name Aya. So yes, there is probably a reason, but the name comes from like the models that were developed before I joined the team. So I'm not sure about the reason, if I am completely honest with you.
Okay.
But
Okay.
yeah,
I
there are
always
multiple
found
reasons.
Cohere's models to have interesting names.
Yeah, we do have interesting names, that's for sure.
Yeah. Thanks.
Yeah, so is it possible to ask a very short question? Yeah, I don't know if we still have time.
Yeah, I gotta go like soon, but we can do one last question.
All right, I'm just wondering because of the last question, is it possible to develop a model that will focus only on low resource languages? Or have you been thinking about this or in this line?
It is possible, but it is challenging because something that happens that is quite interesting when you develop massively multilingual models is that there is some language transfer. That means that when you teach a model one language, it also gets better in other languages because of multiple reasons. But basically, you can think of it as a language transfer. And there are some papers that are quite interesting that you can check out about this topic. So low resource languages actually seem to benefit from being in a model with other higher resource languages because they get some of the capabilities of these higher resource languages and they help each other to get better. So yeah, you can only focus on low resource languages, but maybe you are losing some capabilities that your model can have because it also understands other languages. Yeah, so Aya, I know that Aya is a word in many languages. So I think that's also one of the reasons why it was chosen because of the multilingual aspect of it. It's short and it's a word in many languages. But there are more reasons to that. And yeah, it's a very interesting name. I just don't remember all the reasons.
Yeah, so can I get in touch with you maybe after the program so you could help me with some of the resources you talked about that I can consult?
Yeah, definitely.
All right.
Yeah.
Okay, thank you.
Okay, then yeah.
Thank you very much, Alejandro, for the insightful presentation. So I have a question. I think this will be the last question. So far, I've been following about the tiny higher rather, and I would like to ask, does tiny higher rather support code mixing and code switching tasks, like for low resource languages?
Yeah. Yeah, so I mean, code switching, code mixing is always tricky. I don't think TinyAya is particularly good at that. Yeah, but that's an interesting research direction and something that it will be interesting to explore.
Thank you very much for that. So I think there's no further question. Thank you once again, Alessandro, for this insightful presentation. Like, I've really learned a lot from this. And thank you everyone for joining. Also, you can follow us on our social media handle on LinkedIn and all. And I've actually dropped the community link on the chat box, in the chat bar rather, so you can just fill it and be part of the community and stay tuned for more collaboration and future events and ongoing projects. So I think with that, for the question or any suggestion or anything, that brings us to today's section, like the end of today's section. Thank you everyone for joining and have a wonderful day ahead.
Thank you. Bye.
Bye.
Thank you. Bye.